In this video, I'm going to show you how to graph horizontal translations of the curve y equals x cubed. So here we've got a graph of y equals x cubed, and we want to graph y equals x plus 4, the quantity, cubed. So what does this plus 4 do to the graph is what we're asking here. So now remember from vertical translations that if we had a plus 4 at the end, that would just move the graph up 4 units in the positive y direction. So you might guess that this plus 4 on the inside with the x would just move the graph 4 units in the positive x direction. And that would, perhaps surprisingly, be incorrect. For horizontal translations, things are reversed a little bit. This plus 4 actually moves the graph backwards 4 units in the negative x direction. So this point here at the origin switches 4 units back, goes negative 4 units in the x direction, and it moves to this point here. And then the rest of the graph follows suit. So the rest of the graph looks something like this. So this here would be y equals x plus 4 to the third. Alright, so now that we've got the graph, why is it that the graph shifts 4 units to the left, shifts negative 4 units in the x direction? Why not 4 units to the right? Well, the most straightforward way to see this is to think about points on both graphs. So here we've got some points on the graph of y equals x cubed. 5 cubed is 125, 0 cubed is 0, negative 1 cubed is negative 1, and let's see what happens when we subtract 4 from each of the x coordinates, because we're just shifting all the x coordinates back 4 units. So subtract 4 from 5, so 5 minus 4, and let's get a new point. So 5 minus 4 is just 1, and let's plug that point into the function y equals x plus 4 to the third. So 1 plus 4 to the third is 5, and then 5 cubed is 125. And look at that. Well, the y-coordinate here matches with the y-coordinate that we have before. So we see that the point 5, 125 just ends up moving 4 units in the negative x direction to the point 1 under 25. It stays the same height, but just moves 4 units in the negative x direction to the left. Okay, let's try the same thing with 0, 0. So subtracting 4 from the x coordinate gives us 0 minus 4, which is just negative 4. And we plug that into this function here, negative 4 plus 4 to the third. Well, that's just 0 to the third, which is 0. And there we have it, same result again. The y-coordinate stays the same, so the point 0, 0 just ends up moving 4 units in the negative x direction. Alright, so let's try it on this last point, just to introduce a negative in there. So subtract 4 from the x, and negative 1 minus 4 is negative 5. If we plug that into this function here, negative 5 plus 4 is negative 1, and then negative 1 to the third is negative 1. Alright, same result again. So you can see that all of the points on this function y equals x to the third, if we subtract 4 from the x coordinate, then we get the same y value when we plug it into the new function y equals x plus 4 to the third. So every point is going to be staying the same height, but moving 4 units in the negative direction of x. Perhaps even more intuitively, adding 4 inside of the cube means that x has to decrease by 4 in order to yield the original result. That is, in order to cancel out that plus 4 and get the same y value, we have to decrease x by 4. Here's a really similar example, except on the inside of the cube this time, we've got a subtraction. We've got minus 2. So this is different from the last time when we had a plus. So what happens here? How does the graph shift horizontally when we have a minus inside? Well, when we had a plus, it shifted to the left in the negative direction. So you can probably guess that now that we have a minus, the graph is going to shift in the opposite direction, in the positive direction. And indeed, that's correct. So the graph is going to shift 2 units to the right in the positive direction. So every point shifts 2 units this way, And the graph ends up looking like this. So that is y equals x minus 2 to the third. To verify that this is indeed correct, we've got a table of points here like before. We've got some points on y equals x cubed. 3 cubed is 27, 0 cubed is 0, negative 2 cubed is negative 8. And we're going to verify that if we add 2 units to the x coordinate and evaluate the new point, the new x coordinate, in the new function, in this function here, then we should get the same output for the y. So let's check that. So 3, that's the original x coordinate. We add 2 and we get to 5. Now when we plug in 5 to the new function, 5 minus 2 is 3, and then 3 cubed is 27. So indeed, we get the same y coordinate. So that's telling us that the point 327 just ends up moving 2 units in the positive x direction to the point 527. All right, let's check it for the remaining 2 points here. So 0, 0, let's add plus 2 to the x coordinate, and then we get 0 plus 2 is 2, and then plug 2 into this function here. 2 minus 2 is 0, then to the third power is just 0, so 2, 0. So the y coordinates match up again. And then let's do it for our last point, negative 2. If we add 2 to the x coordinate here, then the x coordinate becomes negative 2 plus 2, which is 0. And then if we plug in 0 to this function here, 0 minus 2 is negative 2, and then that cubed is negative 8. So yeah, great, matches up. Negative 8, negative 8. Y coordinate stays the same when we shift 2 units in the positive x direction. So intuitively, the takeaway here is that in order to cancel out that negative 2 and keep the same output value, we have to add 2 units to the x. And that's why it shifts 2 units in the positive direction, to cancel out that negative. For our last example, we've got a function where we've got a combination of 2 different things going on. We've got a plus 2 inside of the cube, and we've got a minus 5 outside of the cube. So remember that this minus 5 outside of the cube, that's a vertical transformation. So let's label that minus 5, that is vertical. And then this plus 2 inside of the cube, that's going to be a horizontal transformation, as we've seen in the previous examples. All right. So how do we deal with this when there are 2 transformations that are being applied? It turns out for horizontal and vertical transformations, it doesn't really matter which one we do first. We could do horizontal first and then do the vertical transformation, or we could do the vertical transformation first and then do the horizontal transformation. Either one works. But it's good practice to do the horizontal one first, just because the horizontal transformation is a little bit less intuitive. And it's a lot easier to get that out of the way when the function is still centered at the origin. Then once we've got the horizontal out of the way, then it's a lot easier to just apply the vertical shift afterwards. So let's take care of the horizontal shift to begin with. So this is a horizontal shift of plus 2. So that means, counterintuitively, the function is actually shifting in the negative direction. Remember, with horizontal transformations, things are reversed. In order to cancel out that plus 2, we have to subtract 2 from the x input. So we're shifting negative 2 in the negative horizontal direction, in the negative x direction, so negative 2 this way. And then our function would look like that, but we're not going to plot it yet just because we still have a little bit more shifting to do. We have a vertical shift as well, and this vertical shift of negative 5, well, vertical shifts work intuitively, so negative 5 actually does bring down the function by 5 units. So let's do that. Let's bring it down 5. So 1, 2, 3, 4, 5. All right, so the point that was originally at the origin, let's label this negative 5. The point that was originally at the origin here is now shifted down to be right here. and then the rest of the function points on the function follow suit. So the next point is going to be right diagonal from that point. So the next point will be up here, and then our function ends up looking something like this. That way there, and then that way there. So this here would be the graph of y equals x plus 2 to the third minus 5. In the future, we'll also see how to reflect curves and combine reflections with the horizontal and vertical shifts that we've been working with.